going to jump into a CATIA model that I actually have for demonstration purposes. Let me turn this off. So what we have here is a computer mouse, just a couple part assembly. What I'm going to walk you through here is, if you're not familiar with 3DCS, the actual tool itself, we use the CAD data and we create points and use the features within the CAD to build up the tolerance analysis model. So the points here, all these labels, I'm just going to turn those off for right now just for clarity. What we do is we take the assembly process here. So I'm just going to go through and build this particular assembly. So it's building according to how it's built on the shop floor. What this is doing is the reproduction of the build is going to create results that are as accurate as possible. I'm going to build the last couple covers here, a couple moves here. So we have our moves. I'm going to zoom in on this a little bit here. So with the points, these points and these different features, they all have tolerances applied. I'm going to hit deviate. What this is going to do is I can go a little slower, a little faster here. I'll keep with this speed. So what the system's doing is doing Monte Carlo simulations. We're seeing the different gaps here between the cover, even the wheel here is moving around. This is simulating the different builds in a visual format. So what we're going to do is, looking at just some of these gaps, we're going to run a statistical output. So in this case, I will just do 2,000 runs using the Monte Carlo simulation. I'll just override some old results I have here. So what I have right here is the distance between my left cover. So this front gap, let me just slide a couple of these out of the way so we have some clarity. So we're talking about the gap here at the front. So as we can see, we do have a little bit of red according to the spec limits. What we can do within 3DCS is we can move our limits around just to get an idea. I'll leave that one at 0, but my upper spec limit here, tolerance, it was 1. For example, I can move it to 1.5, get an idea of a new PPK. I can also put in a PPK target and have the software identify the spec limits that would be needed to meet that criteria. So the bottom portion of this, these are the contributors to that particular measure. So when we say tolerance negotiation within 3DCS, we can do a little bit with the spec limits in regards to moving those around to obtaining a new PPK. We can also take one of these contributors. I'll just pick on the second one here. So when I double click on this contributor, kind of move this out of the way here a little bit, what the system does, it highlights those features, and with a 0.2 range, I can quickly change this tolerance, and I could rerun the simulation to produce new results. So there's a little bit of what if scenario being done there.
Can you show very quickly on your analysis output how to activate the additional PPK options?
Yes. So in regards to statistical options, I can go ahead and show you the options we have here. Simulation. So for our simulation options, these are all the options you see here at the top. I have PPK on. Some of these other statistics I can turn on and off based off your needs. I can make this as simplified as just showing a few of these. I'll leave that on. Nominal I'll leave on. So I don't have to run the analysis again. Now I've kind of simplified it for maybe some statistics that are more desired than others. So once this report, or once the analysis is done here, we also have the different reporting options. What I can do here is I can pull up our HTML report that we've created for this particular model. So right here with the HTML format, we have, it goes by the different tabs at the top. Our home page, just a little bit of basic information. Model summary, this is where you can put whatever type of information is desired in here. We do have just this template of how we have some customers having it set up with a objective summary, critical measurements, observations, considerations, revisions, assumptions, and there's more things that you can add. So this is totally customizable to your needs. Simulation results. Here's kind of a statistical output. If you hover over any of the actual results, it gives a quick little image on what the measurement is, provides the particular statistics in a table format that's all sortable by one click, or we can type in filters within this box if you desire. If I click on one of these, I can get a little bit more information. We have our bell curve here with the statistics. I also have a sensitivity tab. What this does, it also shows the contributors, highlights them within the picture given, identifies the range and contribution percentage. One other feature here is under the simulation tab, we have animate. So when I hit this here real quickly, you can see the different images. What this is doing is showing the lowest possible image, or the lowest possible gap within an image, and the largest possible gap within the image. Also with the nominal gap image in there. So we have a little text box here in the corner showing what each one is.